21, 22, 23, and 24. To finish off the review, we're still finding reference angles, but in this case it is in radians, so it's a little bit trickier because you're dealing with fractions. I will do 21. Now, in order to deal with fractions, in order to decide if you need to do the first step, again, in radians, the first step, it needs to be between 0 and 2 pi radian. In order to do that, 21, 22, and 24 are all negative, so I know I'm going to have to do the first step because they're all below 0. 23, you're actually going to have to test it. You would have to do 7 divided by 9 and see if the decimal form of that is in between 0 and 2. Because if you remember from a couple videos ago, we don't work with the pi until the very end. So the first step of this, negative 7 pi over 9. I need to get it in between 0 and 2. I know it's not yet because it's below 0. And again, I'm not going to work with pi until the very end. So I'm just going to do negative 7 over 9. And I have to add a revolution. In radians, a revolution is 0 to 2 pi. So I have to add 2 because I'm not working with the pi yet. Negative 7/9 plus 2 is, please, you can leave it in decimal form at first, just to see, 1.222 repeating. I'm going to leave it in decimal form because that helps me check my work. 1.222 is definitely, indeed, between 0 and 2, so I know that I did the first step completely done. I got it where I needed to be. From there, though, if you still have it on your calculator of 1.22222 repeating, you hit math, enter, enter, to give me the fraction form, because I need to work with the fraction form. 11 over 9. I am not quite done, because that's the end. I guess that's the end of first step, the fraction form of it. Now, I'm not going to put pi in there quite yet, because I need to get this in between. I need to find the distance between the given angle, so this is also 11 pi over 9. I need to find the distance between the given angle and the x-axis. Now the landmarkers of the x-axis in radians are 1 pi and 2 pi. It's on the left side, so it interacts with the 1 pi. And if you can tell, as we're going around, since it goes over the x-axis, 11 pi over 9 is bigger than 1 pi. So I always do the biggest minus the smallest. So I'll do this math in green over here. And again, I'm not going to draw pi yet until the very end. 11/9 minus 1 equals 2 over 9. Now, to double check, I will do 2 divided by 9. 2 divided by 9 equals 0.222 repeating. And again, if you remember, radians, this is 0 radians, and this is pi over 2 radians, or 1/2. So it has to exist between 0 and 0.5. 0.5. And in this case, 0.222 does indeed exist between 0 and 0.5. So I can draw my angle and label it as, I ran out of room, 2 pi over 9. And I can bring it right there. That's 2 pi over 9. Again, I only return the pi to the final answer.